Welcome back, everyone, and we're going to continue off where we left off in the last video. Last video, we were creating a cube, and we had basically a neon texture we're trying to build. We're trying to build a kind of neon um, matrixy. What I forget, what did I even call this? A Tron. It's a Tron texture that we found someone else was creating in, I think, Unreal or Unity. So we kind of tried to create this in WebGL. So we got the simple shader. It's got that smooth lines. Now the missing piece is the glowy effect. It doesn't glow. All right. So we need it to glow, and to create a glow effect, it technically, if you're going to go searching online, it's going to call the bloom effect. And the bloom effect is a post effect. That means after the scene is completely done rendering, you then process the scene as a whole further. So that's why we didn't do the glow, because it's kind of more of a complicated animal to set up. So here's the steps of what we need to do to create the bloom effect. So step one, we have to do some setups, and we got to create frame buffers. We got to create a custom frame buffer to draw our scene, because we need to draw this. We got to use the scene as a texture for further processing. Now we got two methods of doing bloom. The first method that you can do a bloom is that when your scene is done rendering, you can use a shader that goes through your scene texture and determines which pixel is considered bright, and that saves it into a temporary texture buffer that we can then use to perform some more effects on it. A second attempt or a second approach is, instead of finding all the bright pixels, you can use multiple render targets in your shaders to, when you start drawing your scene, you can actually then also draw to an emission texture buffer, basically. You can call it whatever you want, but I'm just calling it an emissions. And at that point, you choose what is considered a bright pixel or not. So just a quick look at, because we're going to go number 2, because we want to have some control of what is a bright pixel and what's not a bright pixel. But here's a shader I found. Do I have a link for it? I'm going to have links for all the articles and whatnot that I used to learn how to do this. But this is essentially what you would do when the scene is done. You pass in your scene as a texture buffer. You grab the pixel, and then you kind of use a formula to determine if the pixel is bright. And then you can then do two options. You can do like an if statement, where if the brightness is above a certain value, you draw that pixel, else you draw a blank pixel. Another approach is you just multiply the pixel color by brightness. So you make the bright color more bright, and the color more black or straight to 0 if it's not so bright. Both approaches works. They give you different effects. These two lines of code are identical. I saw one example here, but then you kind of notice that these are actually dot product operations. So you can just do it as a dot product in a float if you want. So instead of writing it out this way, either way it doesn't work. Doesn't matter. And there's two sets of values. These are values based on something called Luma encoding. They have the values of how to determine if something's bright or not. So there's like 3 sets of values for different reasons. So go for it. I was just experimenting which ones does what to kind of see what the effects are. So if you want to go with this approach where you just render the scene and you just want to grab all the lights, all the things you want to consider bright, and then make those kind of glow, that's the approach you can go. We're going to go the second approach. We're going to create multiple render targets, and we're going to choose what's bright or not. So I just wanted you to know that there's 2 methods about it. Only the starting point is different, and at the middle and the end part is the same, no matter which way you go. Because depending on which way you go, you're going to have different buffers. A multi-render buffer is going to have an additional color buffer, where if you're going to do just you're gonna find the pixels. You don't need the additional color buffer in your frame buffer. So step 2, we need to create more frame buffers. You're starting to understand why this had to be a second separate video, because it's a lot of setup to produce a glow effect. So the second set of buffers we're going to create is going to be very simple. It's going to hold only one color texture buffer, and those are going to be used for reading and writing. It's going to be the exact same thing as transform feedback, where we create 2 VAOs, and one set up for reading and one set up for writing, and we just go back and forth. One article mentioned it, calling it like a ping pong effect. You go ping pong, ping pong. So for example, you read from A, we write to B. Then in the next loop, we read from B and we write from A. Because you can't read and write to the exact same buffer, so you have to have one bound for reading and one bound for writing, basically. In a sense. So that's why we need 2, because we need to be to read one from one and then write, and then we swap for every loop to do. We need to do that because it's step 3. So now that we have all our frame buffer set up and we're done rendering our scene, we're going to take, the third step is we're going to blur what we consider bright. So if we have like the first attempt where at this point, like if we're going to use step 1, we're going to have to first use that bright filter shader and write it to our frame A buffer. Everything we consider bright. Then we have to do a blur effect on anything considered bright. If we're taking step 2, where we have multiple render targets, when we get to this point in the program, we don't have to look for our bright pixels, because we did that during rendering our scene. So at this point, we got that step completed. So at this point, we just blur using our emissions texture buffer. So we just blur it, and we have to blur it twice. We have to blur it vertically, and then we have to blur it horizontally. And this creates a single pass of Gaussian blur. And then you can loop this as many times as you want if you want how much of a glow effect you're looking for. Some of you might be asking, why do I need to render it twice? And I don't think I have the page up anymore. Yep, I do. There it is. This article mentions it, shows a pretty good example of why you need to do 2 blurs. Because normally a Gaussian blur, you take a center pixel and then you sample as many times as you want in a radius, and then you get basically a weighted average of what that center pixel is going to be like. So imagine you have to, every time you sample this pixel, you have to grab every single pixel in this radius to get that average. If we're going to do a 2-pass render, so this one pixel, we render just this side and this side, which is render, this whole row creates 9 pixel lookups. So we do 9 pixel lookups, and we just get the weighted average. And then we take that horizontal texture that's been blurred horizontally, and then we blur that vertically, and that creates another 9 texture lookups. And really, 9 is not necessarily the number you're going to be using. You can actually choose how much sampling you want. You'll get more or less blurring based on that. So a 2-pass or single pass will create basically the same blur effect. The only difference is a 2-pass, you'll do a lot less texture lookups. So it's actually a lot faster and less process heavy. So even though you have to take 2 steps, we end up doing less work. So that's why we kind of have that ping pong effect. We have to go back and forth because we need to at least loop twice to do a blurring effect. So that was a good example. So once we're done blurring, the last step really what we have to do is merge our blurred emissions, our blurred glow, into our scene. So you can do it in 2 different ways. You could just draw the blur right on top of the scene using just your regular WebGL and using a blend mode. Or you can take the 2 textures, throw them in a shader, and then blend them that way. And we're going to look at both ways. The second approach, where you have a shader, you actually have a lot more control. You can do a lot of things. So you can probably do, you can combine like certain effects if you want. So like if you want to do glow and there's something else similar to glow, you can then blend everything in one go and save yourself time. So you have more control if you use a shader. But either way works. It really depends on what you're trying to do. If you don't want a shader, you don't need that control, you don't want to waste time rendering another shader or whatever, you can just draw that scene. You can draw your glow texture right on top of your scene texture very easily. And that is the steps of how to create a bloom effect. So now that we get the idea behind it, now we're going to just look at the code of how to approach it. So we're going to have a couple of shaders. We have deferred rendering, which just renders the texture onto a quad. That's all it does. I have a new shader, and I might actually, if you haven't noticed, I have a new folder in shaders called Post. There is actual probably shouldn't have done that. There's a couple of changes to fungi. So I'll post a link as well to all the changes, because there's a couple of changes. Oh. Let's see. So there we go. There's quite a bit of changes. Some to shader. As you see, there's the new post folder, which has a bunch of new post effects, shaders. And some changes to GL as well. So just keep in mind that if you're following along with fungi development, we have to do a couple small changes. So just look at it. They're minor. So I don't really want to spend too much time. I just want to alert it. So if you're not doing those changes and you're starting to do this, things might not work exactly as you planned. Okay, so just look at my GitHub. I'll put a link to the change commit, so this way you can see all the changes that were done. But like I said, they're all really small, like one-liners, just changing little things. Like the biggest thing I changed really is in GL, where I changed, I think it was a texture buffer for the frame buffer. I changed nearest to linear because we're going to do some optimization, and that helps a lot. So that, like I said. So okay, back to the actual code we're looking at. So base code shader is very simple. It's just going to draw a color that we pass in. So we pass in a color, everything's bare bones, it just draws that color, nothing. I made a very simple shader simply because there's going to be a post effect, so it's going to have the least amount of code. It's going to do everything very, very quickly. What else we need? So we go back here. We have a fungi blur, because I read so many articles about blur, so I kind of end up mixing and matching ideas and trying to make my own blur. So we got that. Bright filter, we're not going to use. Yeah, I don't think I use it. So, but like I said, I experimented with it. So you guys can have it if you want to experiment with the bright filter instead. And then we have additive blend. Additive blend is when we kind of just mix the two textures together at the end. So we'll look at that when we come to it. Then we got our Tron Shader, which draws the neon. So there's some small changes to it. As you can see, we got a location set up for our frag color. Frag color is going to be our fragment color that we're going to draw. And we got our emit color, which is set as location 1, because that's our multi-target rendering. Most of it's the same. The only difference is, instead of drawing black for the cube, I decided to add a color to it. So we mix like a very dark gray with the color of the lines for the Tron color. And we use C. C is if you remember correctly, it's the mask that allows us to define the edges of the cube. So using that as a mix, we then just color we just make a color and that becomes our final color that we use for our scene. And then we have the emit color, which doesn't use that color. It uses the neon color times the mask times the strength. So so at this point, when we're rendering, we actually can control how strong our color is as opposed to what's our scene, so we can get different effects. So we can make things more glowy and whatnot. So we had to change that shader a little bit so we have more control over everything. All right. One big change, also in GL, I had to update set color to accept RGBA as opposed to just RGB, because we're going to use additive blending. If we're using additive blending, you have to, the clear color is every time you clear a render buffer or frame buffer, you basically set all the pixels to whatever color you set it to. Now, if the entire scene is set to a specific gray color and we use additive, so if we draw the scene and then draw the scene again with an additive, the two background colors will then add up together and would actually make your scene a lot brighter, like the entire scene a lot brighter, and you don't want that. Since we're using a color or a custom frame buffer, like here's like down here we have our scene that we're saving, we have our emissions. When we say clear, our emissions will also use whatever the clear color is. So we don't want our emissions to actually have a color. That means we're going to automatically bright up the entire scene, and we don't want that. So to fix that issue, we have to set everything to absolute 0. So that's another important thing we need to do for this, and it's probably very important when you start doing post effects. Especially when you use a lot of custom buffers, frame buffers. So this is going to be kind of important, maybe in the future, that everything kind of has to be set as absolute 0, and then we draw everything. But now doing this causes a problem. We need to be able to render a background, which we end up doing. I'll show you in a bit. So, like I said, very important. The set color has to be absolute 0. Everything, RGB and A, has to be 0. It's very important when we do additive blending, because we add up all the colors, and if there's any values in there, these are going to screw up your math. So we need to start with the value 0. We save some references to our shaders that we loaded up, because the render pipeline for Fungi is not very flexible, so we're going to do a lot of things manually, which is good to learn, but at some point we need to abstract all this away and probably fix our render pipeline to be a little bit more customizable, and gives us more flexibility to render things individually and in post effects. So, like I said, step 1, we got to create our frame buffer. So we have our color buffer, our emissions buffer, and our depth buffer, and that's it. That's going to be our main renderer that we use to the main location of where we're going to render our scene. Then, like I said, step 2, we got to create more frame buffers. Right now, you can ignore these calculations. Let me do 5. And I don't want to show that yet. So we're going to create a frame buffer, and we're going to create, and it's going to use the exact same size as our entire scene. But you can customize it. Later I'll show why customizing the second set of buffers is kind of useful. So these are going to be the ping pong ones. These are going to be the read and writes, and it's all it takes is a single texture buffer, which is just one. No, we don't even need depth testing, because, like I said, these are just temporary locations to draw into and to read from. And then we have the quad. This is what we use to constantly draw our post effects. We need some kind of vertice. So quad. That's set up for the entire scene. That's why it's -1 to 1. It just fills up the entire scene. So we have our pre-render function, and in this case, we're going to draw our post quad. Now, when I initiate the post quad, I have the decolor material, which uses the base color. So this is our background. So when we call onRender on our Fungi renderer, it calls on pre-render. So right before it starts rendering the scene, it calls this function. So this allows us to clear out and set our main frame buffer that we're using, our main custom frame buffer. And this is very not very descriptive. The second property, because before you declare it, you need to bind it. And the second attribute or property or parameter of this function states, do you want to unbind it? And I say false, so don't unbind it. So this is very unclear of what this function does. This probably should be called bind and clear, but so just remember this line of code is actually binding our frame buffer that we created right up here. So before we start rendering, we set that up and we can clear it to all zeros, and that's what we're going to start drawing into. We're going to draw into that frame buffer first. And we're going to, like I said, we're going to draw our post function, post really quick. And it uses that single color. So before we draw a scene, we're going to draw our background. So before we never had to draw our background, but because we can't set a default color for our frame buffers, we have to draw our background first. And if you're building a game, that's no big deal because you might have like a skybox. So you're usually going to render your skybox first anyway before you render your scene, so it's no big deal. So it's the same idea. We're kind of drawing a skybox without a skybox. We're just drawing a plain quad that fills up the entire scene, and we're going to fill up the entire scene with a color. So we clear it out, and then we fill it in with the color. This way, because we're only going to fill it up with this buffer. That means the emissions texture buffer still stays at absolute 0. That's how we get away with still having a background color and still do multi-target rendering for additive blending. The glow effect is not easy. There's a lot that goes, especially when you have to build this from scratch. So when we're done rendering the scene, we call our post render function. So we're going to deactivate whatever frame buffer we're currently drawing into. And by deactivating it, we automatically go straight to our scene frame buffer, the one that we've always been using, the default that actually draws to the scene, to the canvas on your in your browser. So once you deactivate it, like you bind buffer to null, that's what's actually happening. Just bind buffer to null, we get that scene canvas frame buffer that we can draw into. And we can just draw our scene. So once we have the scene, we take our frame buffer, we say we want that texture buffer, and we set it on our post effect, and we can draw our scene. And that's what's happening right here. So we're at this point, we're here. This is what we're seeing. Now, if you want to see what the emissions buffer is, we just have to change this to emissions. Emission. Click refresh, and there you go. And you can see that we picked a brighter color because we have in our Tron shader we have a strength, so we multiply by 4. So that's why if we look into our emissions, we have a much brighter color added to our scene or to our emission texture. So now you can see what's in that texture buffer. So like I say, that's kind of a brighter green, and this is more of a regular green. So we're going to mix the two very well together. Now comes the ping pong effect. So let's take this and put it all the way up here. So we're going to set up our blur shader, and we're going to have direction variables. Now, remember I said in the beginning of step 3, we have to do a horizontal and then a vertical blur effect. So we pass into our shader which direction we're going to. So it uses it as a multiplier. So when we do the mathematics of where to, which ones to render, by multiplying this, that means we're going to only move the pixels horizontally, or here we're going to move the pixels vertically. So by sending just those two values back and forth, we are able to have a single shader that that can handle both. Most examples I've seen, they always create 2 shaders, one for vertical, one for horizontal. By just sending in like a direction thing that you can use as a multiplier, you can then very easily have a single shader that handles all the work for you. So it's more like one less shader to deal with, in my opinion. And like I said, once you multiply by 0, that zeroes out. So this way you never move on the X plane. You only move in the Y plane. So it's a nice little thing so you can get away with. We set our viewport drawing size, but this is only important for optimization. Right now it doesn't do anything. Later in the video I'll show you why this becomes very important. And at the very end we also set it right back. So we're going to resize the port and then resize it right back to the size of our actual canvas. But the viewport allows us to control the size of the drawing. Like I said, it's very important for optimization later, and actually makes the effect actually a lot better, faster. Overall, just that optimization trick is kind of really neat. So now we're going to loop. So we're going to loop by 2s. So if I just loop 2, we're going to do the vertical, the horizontal, then the vertical. So, and we're going to use the same simple kind of math that we did in transform feedback. So I is what we're going to draw into, and II is what we're going to draw from. So what texture are we going to use as a starting point? So we're going to clear our temp for FBO, the one that we're going to draw into. That's what I is for. And we're going to choose which texture we're going to read from. So if X equals 0, we're going to automatically use our emission texture. We need a starting point. After this, we're just going to start ping-ponging back and forth between the textures, the custom frame buffers. That's meant for the ping-pong read-write functionality. And then once we have the frame buffer set up, we know which texture we're going to draw from, and we know which frame buffer we're going to draw into. We then set up the uniforms for our blur shader. We pass in the texture, we pass in the direction we're currently using, which uses the same I value. We set in certain values. Kernel length is the size of the array that we're passing in. I'll quickly kind of show you the blur shader. So the idea is that we're going to sample pixels. Like remember this example? We're going to sample. How many pixels are we going to sample? So I have it set up as 3. So that's 3 in one direction. So, but it's really actually 2, because the first one is the center. So it's going to be the center value. Then the remaining 2 is the direction 1, 2, 2 additional pixels. Now these are weighted values. So as you can see, like the center, for every pixel you move, you have a certain weight, and they're kind of normalized. So when they're it's normalized, so this way everything kind of adds up to 1 at the very end. So the center is going to have the greatest weight, and every pixel away from it is going to have a less weight. It has a less effect of the final color value. So you're kind of doing kind of this weighted average, and that's how blur works. You do a weighted average, and every pixel that you sample has a weighted value to it. So the further away, the less influence it has of the center. So the idea is that I pass in the weights of one direction, and I could automatically go in the opposite direction using the exact same weights. And you get these weights by, I got it from this site, Gaussian kernel calculator. You kind of say how big you want it, click 3, calculate, and actually I think I should say 5. Yep, 5. So that's the center. That's going to be the right side, and the further right, this is left, and further left. So for me, all you need to do is just copy the center to the right, and we can use those values for both directions, because it's just addition and subtraction, and the weights are the exact same. See, as you notice, the weights are the same no matter which direction you go. So you don't need to save all the values. Just save the one direction worth of values, and the index 0 is the center. So these are the additional samplings that we're going to do for averaging. And like I said, and I customized the shader so I can pass in a large amount. But since you're passing in an array to a shader, the shader's set up, I think, for like 20 elements. But when you use the shader thinks all 20 elements are filled in. And because it's how memory management happens in C and C++, that memory that it occupies can be full of garbage. So you really need to tell your shader how many elements are you passing in. If you're not using all the elements in your array, you should tell it how many elements are being used. So this way you don't go over the amount that you're using and end up using garbage value, which would then really screw up your math. So, like I said, we only want to move we only want 3 pixels worth in one direction, and that's how we should just move. And we do a blur. And if we're going to look at the FungiBlur, so very simple, not too much. There's no materials because we're not using materials. We're actually calling the shaders directly, and we're setting the uniforms manually. We're not using materials to do that. Because it needs to be customized. There's no point of updating material, then using the material to update the shader. So I just decided, hey, you know what? Let's just access the shader directly, because there's no point in having a middleman. It's too much processing. It's a kind of a waste of time, in my opinion. So that's why I kind of just like screw the materials, and I'm just going to access the shader directly. And we have our uniforms in our fragment shader. So most of it, we have nothing in our vertex shader. Very simple. Doesn't do much. I don't even think we need the UVs. No, actually, we do need the UVs. I'm sorry, we do need the UVs. So here's an example of how you'll find it in a lot of places. Everything's kind of hard coded, and it's probably actually faster to hard code your texture lookups as using a loop, because a loop is more costly as opposed to just lookups. But I wanted the shader to be a way for me to easily test. That's why I'm using a loop. Like if you're very sure about blur, and there's certain blur and it works for your glow, and that's what you can use for the rest of your game, or you maybe have like maybe 2 versions of it, maybe you'll make 2 shaders that are more optimized and does it this way, with all the values already set up. So you do it this way. You don't need to pass the values in as an array. You don't need to use a for loop. You don't need to do additional math. Everything becomes much more simpler. So like I said, when you're making a game and you're very sure of what your values are, this is probably the route you should go. But if you're prototyping, this is the way to go, even though it's not very optimized, because that's the whole point of prototyping. You're testing, you're changing, you're trying to figure out what you want to do. You want to see how it works. So that's why I call it FungiBlur, because this is more just a testing blur function. And like I said, it doesn't do a perfect Gaussian blur, what I'm doing, because of a certain optimization that I'm doing. So FungiBlur does a texture sample. Oh, actually no. This actually gets the size of the pixel. So we need to first, if we're gonna go from pixel to pixel, and by using UV values, we need to know the size of the pixel. And the size of a pixel in UV coordinates is just 1 over the size of your scene, essentially. You can use texture size to get that value. But you really shouldn't. Like it's for, you don't want to actually call this function for every single pixel that you're rendering. So like I said, it's here too, but it shouldn't be here. This is something that should be done outside of the shader, because you know the size of your scene or your texture. It really depends, because if you're drawing a specific texture, frame buffer, like I'll show you later, it's really the texture size. So it's 1 divided by texture size that you're drawing into. Since we're drawing our scene texture is the size of our scene, our entire canvas. So that's all it is, just 1 divided by texture xy. And that gives you the vec2 of that value. So like I said, once I know what the pixel direction, or like how big a single pixel is, I multiply it by direction. So this way I cancel out the direction I don't want to move in. So now I know the pixel size and direction that I'm going. So I'm going to go vertical, or I'm going to go just horizontal. And then I sample the center pixel. Like I said, right here, that center pixel is what I'm going to sample. Then in the for loop, I'm going to sample the left and right pixel. And I'm using a certain little bit of math here. Like this whole part of the math, instead of moving pixel by pixel, instead of just saying, you know, I times pixel size, I'm doing all this math. And all this math is doing is creating a value, like the first pixel is going to be 1.5. The next one is going to be 3.5. Can't type. And the next one is going to create 5.5. Now, you might be asking, why am I going in between pixels and I'm moving away from pixels? Like instead of going 1.5, 2.5, I'm actually jumping. I'm actually that's why I kind of call it the fungi blur, because it's not a real Gaussian blur, because I'm not following the Gaussian blur code. I'm actually trying to experiment and try something different. In a Gaussian blur, like I said, you go and sample everything in the weighted terms. Now, this article from Pyramid Software Solutions has a really neat idea of rendering weighted values. Now, the idea is, instead of doing all these pixel lookups, like these 2 pixels, you can actually do these 2 pixel lookups in 1 pixel lookup. That's why I said it was kind of important to switch everything from nearest to linear, because this example right here is kind of like what a linear pixel alignment looks like. If you were to switch it to linear, it would actually blend. It would be a gradient from blue to that light green. Every pixel, the next pixel will kind of be a blend, really. So if you're going to sample at any point between, so for me to get that perfect blue color, I have to sample, I have to have the UV coordinate exactly at the center of that pixel. So once I get that center pixel value, I will only get that blue value. If I were to have any UV value that goes away from that center value of that pixel, I would actually start getting automatically a weighted value of blue in whatever direction goes. If the UVX value is a little bit slightly in this direction, I would get mostly blue and a little bit of red. And if I get right on that edge, if I draw that edge, let's see, can I zoom in so maybe you guys can see better? If I get that perfect edge, you know what, right here. So if I draw that perfect edge, like if I get a UV coordinate of that perfect edge right between the 2 pixels, I would get a perfectly weighted color between red and blue. I guess what, blue and red makes purple, I think? I can't remember. Or is it red and, no, I think it is purple. I think red and blue makes purple. I'm not sure. I might be wrong. So, like if you think, like I said, these 2 pixels, if I get this dead center, I get blue. If I get this dead center, I get red. If I were to somehow just get that UV coordinate that really hits the right in the center of 2 pixels, like right in the middle of the border, I would get 50-50. It would automatically give me a pixel value that's basically purple. So having everything set as linear, you can automatically do weighted lookups of pixels by using the system. You don't have to code it yourself. So there's an optimization trick where you can merge these 2 together and merge the weighted values. And this article has the equation right down here. You can calculate this outside the shader, and this way you calculate the actual weighted values, and you have to calculate the weighted values and the offset. It's very important. You need both. So you need the offset and the weight. So that means you also need to know the width of a pixel on top of that. So like it says offset a pixel, that's really the width of a pixel. What's the width of pixel 1 times the direction? So it's like this might be width of pixel 1 times 1, which is just 1 pixel over. Texel 2 is width of pixel times 2 because you want to go to the second pixel afterwards. And then you take the, like I say, if you calculate this outside the shader, you can pass it into this function, and you kind of get that if you want. But I'm actually doing this automatically, so I'm just automatically taking the values. Like I'm using the values as if I'm going 1 pixel at a time, but I'm actually going to hit dead center of every pixel. So this way I end up double sampling. And the reason why like I'm going from 1 to 3 to 5 is that I'm going to go to this instead of going to 2, which is the next pixel over. I'm going to skip that and do this. So I do it groups of 2. So I'm mixing these 2 greens together, and I'm mixing these 2 greens together. So I'm getting these weird blurring effects going on. It's not weird blurring effects. I'm just like I said, I'm experimenting with blurring. So I'm kind of, so instead of so this version of blurring, instead of me going sampling 1 pixel at a time, I'm actually sampling 2 pixels at a time by the process of using linear lookups, and then calculating the dead center border of 2 pixels. So, like I said, so you can go online, you can find boatloads of textures. I actually have tons of them, to be honest, already. Show sidebar. If you go to shaders post, I have something called fast gradient blur. This was originally what I first started using until I started to see and start making my own just for funs, because I'm crazy like that. Yeah, if you go into this shader file, it'll be in the GitHub. These are just regular. Like there's one from GLSL Fast Blur GitHub. They have like different versions of it. This is the one from Learning GL. I think they use a for loop as well. From Pyramid, that's how they do theirs, and another one, and so forth. So there's a lot of blurs I tested and experimented with and played with, and like I said, mine's is a version of mixing all of it together. And like I said, merging them all together with my little flair where I'm doing this instead of going to 2.5 and 3.5. I'm skipping. I'm doing groups. So like this one's like my own slight variation on top of that people aren't doing. Because I was curious. I was curious if I were, what would the blur look like? And the blur looks kind of the same. So so why not? Just go for it. But the equation here is if you want to get exactly what a Gaussian blur is, and you want to use the optimization trick, you kind of have to calculate it this way. So this way, it kind of merges these 2 values together. It merges the 2 offsets and it merges the 2 weighted values perfectly, just right, where you kind of get all that automatically. So, again, and that's it. And fungi blur, you pass in your texture, the UV coordinate, and the direction that you're trying to get to, and that's all. Like I said, I first tested it this way because I was trying to make sure I get that middle pixel, and I just turned it into a for loop, so I can then choose how many samplings I can do at any given time. So if I didn't customize this myself, I probably didn't have to explain the blur. But since I'm doing this custom thing that you probably won't see at all, really. Like I said, this is the only article that I've seen that mentions that optimization trick, which is kind of neat. So I kind of like it. I kind of like the idea that you can work with the system to eliminate certain things. All right, so like the idea is I can actually just pass in 1 pixel and I can automatically get 2 pixels worth of blending. So you save processing that way. All right, so now we're done with the blurring, and yeah. So we blur it, we ping pong. We have to do it at least twice. We got a left and right, left, right, top, bottom. Before I had this loop, this is how I did it originally when I was initially prototyping it. I would clear the FBO, set up the shader, draw. Then I go to the other FBO. Like, see, this one is 0, and now this one's 1. Set that one up. Set up the buffer, draw. And this is like one Gaussian blur setup. But I changed it where I only have to do it. I only coded it once, and it loops, and I alternate back and forth between vertical and horizontal. And if I want to sample it 4, 6, you know, this how many times do I want to blur it? And you actually sometimes you have to blur it more than once. We had to blur it more than one full cycle, so you might have to blur it 2 times or 3 times to get a really good glow effect. All right, so all said and done, let's see what the blur looks like. And let me disable all blending. So I just want to draw the temp color buffer, which has our blurred effect. So I click fresh, and I broke something. What did I break? Oh, that's right. I put the comment in the wrong spot right there. Refresh, and there you go. And it's hard to tell, but it's slightly blurred because we're only blurring 3 pixels and we're only using 1. If I were to, let's say, do 2 cycles or 2 full blur worth of effects, now it's a little bit more blurry. For me, sometimes 6 does a really good job. There you go. Now it's nice and blurred. Nice and blurred. Perfectly blurred. Yeah, so there you go. Now you got a nice good blur. If you really want to blur it like crazy, you can do 5 cycles worth. Refresh, and it's nice and blurred. At this point, if you're doing 10, and depending on which computer, you might see a frame drop. I'm still going at 30, which is fine because this screen that I'm using a large TV actually as my monitor, and it only has a frame rate of 30 anyway. I have a tablet PC where I do a lot of my work, and it has a frame rate of 60. But when I start doing a lot of blurring effects, the frame rate actually drops. Especially if I use this one, a lot of sampling at 5 times each. It really drops my frame rate. And there's some optimization tricks that I followed from this article that actually got my frame rate back up to like 40 or 50. So, but I was pushing it. I really was pushing the blurring. Like if I take the optimization tricks and then bring it down to like maybe 6 and then use 3, I have the blur effect working just fine and I have maximum frame rates on my other PC. But in my tablet PC, it doesn't have a good graphics card. It's a really bad graphics card. So, because it's not really meant for that. It's like I can't even run Unreal Engine on it at all, to be honest. It's not good for gaming. It's great for development, or it's great for programming, not game development. So that's why I have a desktop PC for game development, which I use for recording. Which, no matter how much I blur, the frame rate's not going to drop. It's always going to give me the maximum frame rate, whatever screen I'm hooked up to. So keep that in mind. Like if you start changing these numbers and your frame rate drops, that's probably because your PC can't handle it. And there's some so we're gonna go at the very end. We're gonna look at some optimization tricks that actually improves the blur, but at the same time increases your frame rate. All right, so let me bring this back down to 6. You know what? Let's keep it at 10. This PC can handle it. All right, so there's a blur effect. Now we can just say blend. We want to blend it. Both these blend modes give you the same effect, so there's no big deal. The idea is that these don't modify. Well, this blend mode does not modify the colors. So this one says the color coming from the shader, and this is the texture that already exists there, or the pixel that already exists on the scene on the screen. Basically, it's saying don't modify, and at the very end, don't modify the values, but they just add them up together. This one, the pixel that's on the screen, don't modify, but the pixel coming from the shader, modify it. Take the alpha value and multiply the RGB. So this way, if you have an alpha setup, it automatically apply basically the alpha value to the RPG values and then adds them up. And this way you kind of get that opaque color if you're looking for. So if you're using opaque colors, this blend mode is what you probably really want, as opposed to this one. So they're both additives. Actually, every blend mode is actually an additive, but then you have, but this is kind of like this is like a complete additive. That means it just the two values unchanged, add them together. Every blend mode has a different function. Like by default, this is the default. So if we get like perfect like blending of alphas, this is the blend mode we have set up by default. And I'll explain why I have all this crap at the bottom at the beginning of the function. So here we go. So we got the blend mode. We're going to activate our post shader, which just draws a texture on the scene. That's on the screen. That's all it does. And we're going to use that frame buffer. And we use I because I will always contain the last frame buffer you drew into. So since you know I is going to be the one that gets drawn into it, so it's the last one. So just that's why I keep the I value outside instead of initializing it inside the for loop. Because if I initialize the I inside the for loop, I can't access the I value. So sometimes you might catch me setting these values outside the loop. Like sometimes I might even set like the X outside the loop because I want to know what the last value is after the fact. So this way, I is the last time we drew, so that means it's this texture. At the very beginning, we draw the scene. So the scene is already on the screen. So the entire scene is drawn in the scene. Over here, like I said, if I take away the blend effect, you see the blur, but that's because I took off the blend effect, and it's just drawing right on top of it. That's I'm drawing right on top of the scene, so I'm kind of basically wiping it out. Now, if I set this up, like I said, if I set up the blend effect, now we're going to blend the colors together. Click refresh, and there we go. Now we got our cube finally glowing. Now it's glowing. Now it's got that nice Tron glow going on for itself. Ta-da! The end. The end. Now, like I said, there's two ways you can do this. You can do it this way, or you can use the shader. So if I go over here, this time I'll make sure I'll put it right at the end of the text instead of on the line. So I activate the blend shader. I pass in our scene, and I pass in our the texture, the blur effect. Actually, I just want to doubly make sure. Because now, if we're going to blend the two together, we don't need to draw our scene. Like up here, I'm drawing the scene. So at this point, I don't need to draw the scene because I'm using the shader to combine the scene with the blur. So now refresh. On post effect, I'm drawing nothing. There's nothing on the scene because I'm not doing anything in post effect. So the scene is still empty. So now, just to prove that this is going to actually blend it together. So like I said, we're going to put in our scene texture, we're going to pass in our blur texture, and we're going to draw. Click fresh. And I broke something again. And because I did that again. Refresh. And there you go. There's a scene, and it does the exact same thing. You barely notice the difference. Now, additive blend. This is the shader. It's very simple. Like I said, it's you can basically say this is like a simple post-effect shader, where everything is kind of done on the fragment side. Now, like I said, the reason why you can say you can have some control over it is because you can, at this point, you can modify it. So right now, there's the base, and this is the over. This is the blur effect, and that's the scene. And I can then multiply the over by some value. So right now, I'm using that because I don't want to change it to 1. But if I want to, I can then say 5. So if I look over here, see how the glow effect would then empty cache and refresh. It's a little dimmer, you probably can't tell. But if I do 1, then you probably can tell now the glow is gone. Like the glow is completely gone. So if you wanted to, you can actually animate the glow. You can have your entire scene glow together, like in sequence. So this, you can kind of animate this over time. So you can, so it, like that's like an option if you want. Like if you want to make, like let's say you have everything in neon, like everything's mechanical on the scene. You can have everything glow in unison. So if you want to do that, if you want to do that kind of thing, so like that's why I kind of said if you want to use a shader, you can then do a lot more control over it. The Learn OpenGL Bloom tutorial, they have a bunch of things they do, and it really screws up the scene for me. But let's see. But that's because they're using, yeah, like it really. But like I said, you have a lot of control over the scene. So it's doing like tone mapping and gamma correcting, and like to me it really screws up the scene for me. That's why I was like, you know what? But the reason why they're doing all this calculations because this tutorial feeds off another tutorial which does HDR rendering. So when you're doing HDR, basically it's another blend mode, another post effect basically you can do after the scene. So it's the HDR rendering. It's supposed to make the colors pop. It's supposed to make your scene look really good and really bright. So if you've ever seen like HDR like TVs and stuff, they look really good. So apparently when you do that and then you add bloom to it, you kind of have to do these other things. You kind of have to do like a tone mapping and gamma correcting, and then your final scene will work. So that's why I have this here, and so just as a reminder that maybe at some point I want to go back and check out the HDR post effect, and then I have this as an example of like how to fix it if I want to use bloom on top of that, because HDR kind of does a bloom kind of a thing to it brighten things up more, and that's why the entire scene is kind of brightened up, or like it's a dark scene, but it's got changed over like crazy. It's probably the whatever. So so yeah. So there you go. There you go. Back to what we want, and we can just set it to 1 now if I want to. So this is perfect strength. Like this is the glow how it's really supposed to look like. So there we go. I want to explain these parts really quickly. I'm only changing blend mode here because here I'm changing the blend mode and I want to set back to default. So that's why that's there. Use program, no, I'm just clearing out the existing shader. I'm just doing cleanup. Here I'm enabling depth testing again, and I'm enabling depth writing. At the very top, I do the exact opposite. I disable writing and I disable depth testing. Because if you're doing post effects, depth is not important because the scene is already completely rendered. You don't need to worry about it. I think in you might have to like the shield. In the shield videos, we had to do depth testing. We had to disable depth writing because that screwed it up. But I think we still needed depth testing turned on. I'm not sure, can't remember. But I think, like I said, for most of the part, you need to I just turn it off because we don't need it anymore, and it makes it easier. So this we can draw on top of things over and over again, and not worry about depth testing kind of screwing up with us because we're drawing a lot of things on top of each other. So. And post effects. So it's in good practice to kind of disable this stuff if you don't need it. If you don't need it at all in post effect, disable it. Do all your work and then turn it back on for scene rendering. That's one of the things I want to change in our pipeline to be able to control this automatically instead of having to do it manually. So have it where certain objects can request the feature to be turned on and off. Would make life a lot easier than having done it manually. The last thing we can look at is an optimization trick. This part. why this part is important. So let me set up. All right, get rid of that because I want to be able to see certain things. Do it here. Get rid of blending. Yeah, let's draw our scene. So I'm going to switch back to regular blending just to make it easier to see certain things. Click refresh. All right, there's our blur. All right, so we're doing our blur thing. Now up here, like I said before, we have our fragment shader, our custom text buffers. Okay. Right now, we're creating our temporary frame buffers that we're going to use for blurring the exact same size of our scene. Now, when we do blurring, you're basically blurring the entire scene. If you want to optimize it, you can shrink the scene, essentially. So, and it's not like we're shrinking the scene. We're actually going to shrink is just this texture that we're drawing into. So the textures that we're reading and drawing from can be shrunk down. You have to keep the exact same aspect ratio. So that's why I take the width and height of the scene and just multiply by the same one. As long as the width and height are the exact same ratio, things will render just fine, but at half the size. Now here's the thing. We're going to shrink down the texture. We're going to draw into the texture at a small size. Then we're going to basically resize it back up to the size of the scene, which actually causes the blur to actually get bigger, which creates a more glowy effect. But at the same time, when it's shrunk down, we have less pixels to process the gradient blur. So if we have less pixels, we process faster. So this is how, if you're trying to do a lot of gradients, like I said, doing like 11 samples at 5 full blurs, your frame rate's gonna drop. This is one way to actually increase your frame rate. So by eliminating the amount of pixels that you're actually blurring. So if you have less pixels to blur, you usually finish the processing faster. So right now I'm going to say half the size of the scene. I'm going to say width and height. And so this way it's half the size of the scene. So when it gets to this point, it takes the FBO frame width and frame height, and it resizes the drawing port. The port controls the actual size that we're drawing at. If you don't do this, it'll look really weird. I'll show you in a second. So if I click refresh, now you notice things are even more blurred because, like I said, we shrink down the texture, we draw it, and then we blow it back up. So if you're stretching it, you're making it bigger, and it actually makes an even bigger blur effect. So you can actually get away with less blurring. Like you don't need to go 10. I can go maybe even 4 at this point, and get the original blur effect that we had. So I'm doing less processing because that automatic stretching makes that blur effect actually bigger. You're just like zooming in or something, essentially. So yeah, like I said, I can probably shrink this down and still get a pretty good blur and a much more optimized. And if I were to mix it, you still got the blur effect, and it's faster. Like our frame rate is nice and solid. Like it's 30, 31. There's gonna be no frame. Well, like I said, this PC is not gonna hit a frame rate. It's like on VR. This computer works pretty well. It's not a 1080. It's like a 970 to 970 NVIDIA chip. So it's like the requirement, but not the really good version. What you like the 1080s. The 1080s are supposed to be like really great for VR, but I got the 970s, which is what Oculus when they first came out said that's what you wanted. Even though I don't have an Oculus, I have a Vive. But besides the point, yeah, so by shrinking it down, you actually, like I said, you can still get that exact same blur effect, and at less processing. So if I were to go back to 10, because I wouldn't want to push it again, I get a lot bigger blur effect. So, so like I said before, when we're using the full scene, we had a thin blur, a thin glow, and just by optimizing it, we actually get a bigger blur, which is good because it gives us that more of a glowy effect. So like when you zoomed out, you kind of see more of the glow because we're stretching it out. But like if you want to make it a little bit more uniform, you can just then process less, and you end up getting back the original glow that we had when we were using 10. Yeah, and a very good glow effect. And you know, you can go as far as you need to. You might see artifacts because when you're basically resizing it back up again, you might get artifacts. But since you're blurring it, it's blurred. You won't notice it too much. Like I said, now I'm doing it 0.25, and it still looks pretty good. And the blur effect is bigger, but when you resize, you'll see little weird things happening. But that's because of the artifacts of resizing up. If you need to not blend at all, you can kind of see what the texture looks like. So yeah, there's artifacts by resizing it back up again. So when you're choosing the optimization, you can play around with the numbers and see what works for you, and increases your frame rate to where you're happy, and it still gives you a good effect. Like 0.25 is too small. You know, I can really go 0.1 if I want to. Now it's really bad, but who knows? Maybe that's the effect you're looking for. You know, who knows? But yeah, it becomes much more pixelated. Do 2.5 maybe 1.5. I mean. And let's blend it into the scene so we know what it looks like. I don't care which blend mode. And you can see just by resizing it and creating those artifacts, you kind of get a different look. It kind of like every time you rotate, it kind of looks like it's shining on. It's a little funky, but who knows? Maybe it's an effect that you're kind of looking for, and you automatically get that effect simply just by optimizing it. Essentially, it makes the frame rate, you know, it'll improve your frame rate because you're less processing. And yeah, I'm doing 10. What happens if I blur a lot? Like, so it's not as bad. It's still there a little bit, but it's not as pronounced, and the blur is a lot wider. So I still don't like it when you move. So you kind of have to play with the numbers until you find something that you really like, what feels comfortable for you. So like I said, that I think 5 is good. I probably can try like maybe like for my screen, maybe 3 might still work pretty good. You still get artifacts. I think 5 might be like the safe bet, like half the size of your scene. Yeah, like for me now when I rotate, the glow doesn't have this weird effect. So half works out really well. And yeah, I only do 2 Gaussian blurs, and I do it at 3 samples. You can increase the samplings if you want, and it gives you more of a blur effect and things like that. Like I said, you can play with it, and that's why I built this version of the blur effect, which I'm kind of doing that in between automatic blending, and then I'm doing this weighted blending on top of that. Like I said, you can try different blur functions to really see what feels comfortable. What any blur will do, as long as it creates some kind of blur, you can do it loop it as many times as you want, and then just blend that color in, and that's how you create a glow effect. And there you go. And we finally have our Tron effect completed. It's done. It's optimized. It looks pretty good. We got 3 samples. We're only blurring it twice. And it glows. It's good, and like I said, we can blend it any way we want. And that is the end. And my throat is finally starting to crack. So This might be a really long video. Sorry, but like I said, there's a lot that goes into making the bloom effect. Um, it's not like it's not like the Unreal Engine or the Unity engine, where it's kind of just an option you turn on. Now, when you use Unity and Unreal Engine, and you turn that option on, and when you drag that little connector to the emissions in your like Shader Forge or whatever graph tool you're using to create shaders, this is what's happening in the background. This is what's really going on. This is what's happening to create that glow effect on your scene. So, if you're completely oblivious to that fact, now you're not completely oblivious to that fact. I'm no longer oblivious to that fact. Now, every time I see it on the screen, I know exactly what's going on. I've been doing this for over a year now. When I play video games, I'm starting to pay attention to things in my games, and I'm like, okay, I know what that is. I see that glow, especially when it comes to Zelda, and you have the Guardian weapons. They glow. It's like, I see. I know where that glow is coming from. I know how it works now. So, knowledge is key, man. Knowledge is key. Everything is indistinguishable with magic until you understand how it works. Before, when I was just a plain gamer, how games worked was complete magic to me. Now that I'm trying to become a game developer, or actually a graphics developer, because I rather kind of want to be, or a graphics developer, it no longer it's magic. To me, now it's just mathematics and process and data structures. So, hopefully you guys are enjoying yourself, because, like I said, this stuff is fun. This is really good stuff. It really helps to learn, and it's tough stuff. It's very tough stuff, and if you're sticking with it, good on you. If like I said, if you want something if you want something bad enough, you're gonna have to go the extra mile for it. So, here you go, blur effect. I've been waiting over a year to do this, and like I said, I'm finally at a point where I can understand and actually do this. And like I said, I'm making my own blur functions. That's awesome. How cool is that? For years of using Photoshop, never understood how blur effect works. Now I completely understand how blur effect works, and I know how to optimize it. And how awesome is that, right? All right, I think I'm wasting enough time BSing at the end. So the usual BS, like and subscribe. I know it's BS. I don't even get ads anymore. So, but I got kicked off the ad program. But yeah, just still like and subscribe. Why not? I still want that trophy that when you get 100,000 subscribers, you get that little trophy that says not a trophy, it's like an award, but I want that award that says Sketchpunk Labs. That's like my goal with this channel. I think one of the mini goals, a side quest essentially of this tutorial series, is really can I get that award someday. But I need your guys' helps. You guys just clicking that subscribe button basically helps me with my side quest. So, yeah, I don't care. Subscribe if you want. I don't care. Like I said, I'm here for the work. I'm here for fun. So, like I said, it's a side quest. Who cares? The main story is actually getting the stuff done and working. So, I know I live in an RPG world. I'm spending too much time playing Zelda. All right. I guess I'll see you guys in the next video. Enough is enough. Bye.